continuing malfunctions, we're going to start with the calculator page. So on your practice test 1, the first page is no calculator, and the second page is calculator. So we're going to start there because that's the part that I know hasn't videoed. Okay? So here's what I need for you to do. We're on the calculator page, starting with problem number 8. And first thing, let's turn our calculators on and make sure that we are in degrees. Okay? So we're going to mode and making sure we're in degrees. I am. So now I'm going to do problem 8. And I'm going to do degrees, minutes, seconds. So here we go. You guys all got one of these before. I'm going to not make any more extras if you can't take care of your stuff. Okay, those are supposed to be for emergencies, not just because you're too unorganized to keep your stuff. All right, so 18.775 second angle DMS. We're changing to degrees, minutes, seconds. That's DMS. So it's 18 degrees, 46 minutes, and 30 seconds. Okay? Now, this next set, you will notice some of the problems are in degrees and some are in radians. So, I'm going to go through, since my calculator's in degrees, I'm going to go through and do all the degree problems first. Then I'll go back and do the radian problems so that I don't have to keep switching. So the very first problem is a degree. So I'll do sine 28 second angle degrees, 14 second angle minutes. This is nearest 10,000. That's 4 decimal places. 0.4731. 0.4731 is what you should come up with. All right, I'm going to skip the next couple. Why am I not doing the next couple right now? They do not have degree marks, right? So I'm only doing the ones with degree marks. So I'm going to D. Secant 1 divided by cosine 19. Secant is the reciprocal of cosine. So to do a cosine, we have to do the reciprocal. To do secant, we have to do the reciprocal of cosine. 1.0576. 1.0576 is the secant of 19. Next one's a no-brainer, cosine 98. Negative 0.1392. By the way, you do have the answers to these in Schoology, so if you don't get something written down and you're not getting the right answer, you can always work on it later. How about F? F is a tough one. What do we do about F? Ethan?
So 1 divided by sine,
yep.
And then do all the 15 stuff?
1 divided by sine, 15 second angle degrees, 19 second angle minutes, and 11 alpha plus. Remember, that's the weird one. 3.7849. 3.7849. Now, I've done all the degree problems, so now I go to mode, change myself into radians, right? And then start typing. So tan 1.15 is 2.2345. We're all supposed to be typing right along with me. And then C, I have to do second cosine, 0.376. 1.1853. Now, on your test, just like on here, this whole sheet, I know we've only just started it, but the whole sheet, the only problems that are radian problems on the calculator are those that we just did. So let's just switch our calculator right back into degrees right now, so it's ready to go. Try to remember to do that on test day. The only radian problems that you're typing in on your calculator are in that section that we just finished, number 9. Everything else is in degrees. So you'll want to have your calculator set in degrees. Okay, so speaking of which, look at the next problem. It is a degree problem, number 10. All right. Now, this is like a word problem, except there's no words, you don't have to do it. You need to set up an equation. Oh, shoot, I need to take attendance. Who's missing? Anyone? Oh, Madison and Bart. And Ian. I thought I saw Ian earlier too. Alright. What kind of equation am I setting up here?
A sine equation.
Well, yeah, it's going to be sine, cosine, or tangent. Which one? Cosine. Very good. Cosine x equals 11 over 14. For those of you that are sleeping, she knew it was cosine because here's her angle. Now, it's in a different place than usual, but that's okay. They put it there. I didn't put it there. This is adjacent. This is hypotenuse. So she used cosine. Perfect. Now, how do I figure this out? Do not multiply by 14. Do not. Nope, I don't add, I don't multiply, I don't do anything except what? Second cosine, very good. When x is your angle, you don't mess around. You just second, in this case, cosine. Okay? Give me an equation. Sine, cosine, tangent, it's tangent. Tan 28 equals 13 over x. Now this one has to be solved. Look at that equation, look at this equation. They are different. When the x is over here, you have to solve it. So I'll multiply by x and divide by tan 28. So, 13 divided by tan 28, 24.45. Now I'm going to draw a course, and that's all I'm going to do. I'm just going to draw the course, and it's 118 degrees. So I have to remember when I'm on a compass that this is the way I label it. Somebody last period said, but Mrs. Ford, usually you start here. Usually this is 0. Yes, in math class that's 0. But on a compass, this is 0. So 118 degrees would be like right here. That's it. That's all you have to do. Get it in quadrant 2, or quadrant 4, I mean, and you're all set. That's all you have to do. Now this next one, we're actually gonna do two different ways. We're going to do it on the calculator, and that gives us a decimal. And it's very, very simple. It could not be any simpler. Type in exactly what it says. You do not need to put the parentheses in, they pop up automatically. So sine, second tangent, 2 divided by 5. That's all there is to it. 0.3714.
Yeah.
And that's the decimal answer. Now, if I'm doing it by hand, we talked about these problems the other day. Forget this for a moment and draw a picture of this. Since that's a positive number,
Goes in the top one.
it goes, top right's called quadrant 1, so we're gonna put it in quadrant 1. And tangent is opposite over adjacent. And then I can do the Pythagorean Theorem to find my hypotenuse. A squared plus B squared equals C squared. So the square root of 29. Then I can answer the question, which is, what's the sign in that picture right there? 2 over root 29, which is 2 root 29 over 29. This is the exact answer. So that problem we actually did twice. Once by hand, using our brains, and once just typing in on the calculator. Very, very easy. All right. Oops, I'm on the wrong page. Now we have our word problems. The test won't have 5. I just put 5 on here for extra practice. But you will have some. So here we go. We've got the squirrel sitting in the top of the tree and looking at a nut on the ground. All of these problems involve something up here looking at something down here, right? They all do. Okay, what do I know? The tree is, 76 feet tall. And the angle of depression is 37.8. Find the distance from the nut to the base of the tree. Almost always when kids miss these problems, it's because they labeled their picture wrong. Where do we put the X? At the bottom. From the nut to the base of the tree. What's this distance? This would be from the nut to the squirrel. You gotta read. Take your time, slow down, read it twice if you need to. Now, write an equation, sine, cosine, or tangent. Tangent, 37.8 equals opposite over adjacent. I'm gonna have to solve this, so x tan 37.8 equals 76. And x equals 76 over tan 37.8.
97.978.
That sounds about right. 97.98. And always put a unit on your word problems, so that would be feet. You will lose points for rounding incorrectly. This says round to the 100th, right? So the 100th is 2 places.
If you don't tell us, does it matter?
No, it doesn't matter if you're not told. All right, a seagull on top of a lighthouse. Here we go. Here's the seagull on top of a lighthouse, looking at a fish. The gull is 78 feet above. The gull is 320 feet from the fish. So where do I put the 320? Hypotenuse. There's the gull, there's the fish. They're 320 apart. What would this be? The distance from the fish to the base of the lighthouse?
Yeah.
Or fish to shore? Find the angle. Alright, so here we go. Sine, right? Sine, I gave it away. Sine x equals 78 over 320. How did I know sine? Opposite and hypotenuse are my sides. Now, how do I solve that? Look at it. Second, this is x equals second sine 78 3/20. Don't be messing around with them if that's the x. So second sine 78 divided by 320. 14.11. And that would be degrees. That's an angle. So its unit is degrees. All right, now we have an airplane. Looking at an airport. Here's the plane. Here's the port. By the way, don't forget about math week tomorrow.
I'll see you tomorrow.
Yep, math week's tomorrow. Also, we'll practice next class. We'll do another practice test. Class after that, we do another practice test. The one after that's the test. So plan it out. I don't have any idea what day that is, but 3 G periods from today, we have our test. Okay? All right. How far is an airplane from the airport if he's 6,543 feet above the ground and the angle is 23 degrees? Does that picture make sense? Sine, cosine, or tangent? Sine 23 equals 6,543 over x, opposite over hypotenuse. So x equals 6,543 over sine 23. Oh, 16,745.53 feet.
For ACT, do you have it on Wednesday?
What?
Do we have it on Wednesday for online?
We'll have class, we won't have a
Video.
test on an online day, but we'll have class, that counts, yeah. All right, here we go. Find the height of a flagpole. It makes a shadow 31 feet long when the angle is 29. Where do I put the 31?
On the bottom.
On the bottom. So many times. Kids put that 31 on the hypotenuse. No, 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 it's a shadow. It's on the ground. Sine, cosine, or tangent? Tan 29 equals x over 31. This is an easy one. X equals 31 tan 29. $17.18. I know these get a little boring, there one more, here we go. This time, we have a man looking at the top of the building. It's 84 feet tall. We want to know the angle, and the man is standing 1,234 feet from the building. Where do I put the 1,234? On the ground. Here's the man standing right here. Here's the building. What would this be? Well, if I'm standing down here and Tom Ford's up here, then that would be the distance from me to my husband, right? but the distance from me to the building is right there. Sine, cosine, or tangent? Tangent. So tan x equals 84 over 1, 2, 3, 4. Whoa, how do I type this in? Second tangent. So second tangent, 84 divided by 1, 2, 3, 4. 3.89 degrees. Now, that is it for the calculator part, but because, that's still running, Jose?
Yeah.
Awesome, thank you for all your help. Because I'm not exactly sure when it stopped, let's go ahead and do the graphs. And in fact, we might just work our way through this thing backwards. The order doesn't matter, so we'll just work through it backwards. So let's do the graphs now. We just took a quiz over this. I have not looked at them yet, obviously. However, I did have a chance to look at one class, and one thing that happened to some of the kids is they had the wrong shape. Kids, the labels don't really matter if you don't have the right shape. So let's just go through this practice test, which remember looks like your test, and let's just put the shapes in. So this is a cosine. Cosines are like the skateboarding things, or the snow, those things where they, go up and like this. That's what a cosine looks like. So start the guy up here, he comes down and back up to the top, and then he stops right there on the other side. That's a cosine shape. Now the tangent is totally different. The tangent has an asymptote and an asymptote and a squiggly line through the origin, right? That's the tangent. Yeah, we're going through this backwards. So it's practice test 1, problem number 7. And then we have a sine. Now, I pay attention. Normally, a sine would start at the origin and have a hill and then a valley, right? But this one is upside down. So it's going to have a valley and then a hill. And one of the quizzes, I think, had an upside down sign on it. Some of you did have to do that. Okay, so now we have the shapes. Now we can go about putting in the labels. We know that top and bottom of a cosine is the amplitude number. We know that we have to label where it crosses, where it bottoms out, where it crosses, and where it ends. And normally those are 90, 180, 270, and 360.
So we're gonna divide it.
You are responsible for knowing that. However, the labels of the actual picture won't be these, because we put this in there. What does that do to those labels? It divides them by a fourth, which is the same as timesing them by 4. So this one is actually 360, 4 times 90. This one is 720, 180 divided by a fourth, or 180 times 4. This one is 1080, and this one is 1440. So this cosine has an amplitude of 2/3, an amplitude of 2/3, and a period of 1440. Now our tangent picture, which has the asymptotes and the squiggly line, the normal asymptotes are at negative 90 and 90. Right? But, wait a minute. Aren't they still at negative 90 and 90? Because there is no number stuck in here, right? And that is the number that changes the width, changes the labels. What's the amplitude of this? There isn't an amplitude. Not applicable. No amplitude. And the period is 180. The only way you change these labels is by sticking a number in here. I didn't, so I didn't change them. These are going to change. Amplitude's 3, right? Amplitude's 3. Normal labels, which would be bottom 0, top 0, would be 90, 180, 270, and 360. Those would be the normals. But they are being, there is a number now, they're being divided by 2/3, which is the same as timesing by 3/2. So 135, 270, 405, and 540, if my math is right.
Yeah.
So my amplitude is 3, and my period is 540. So hopefully you did that on your quiz. If not,